Good afternoon. My name is Jacob Coleman, and today I'm going to be doing the report presentation on the ranking cycle for Section 4, Group 1. My teammates are Greg Adams, Miles Bourgeois, and Locke Maxson. And before I start, I want to say thank you to Daniel and his group for sending data for this presentation, because without it, I wouldn't have one. Right, so let's lay out this presentation. So we're going to start with a refresher on the ranking cycle. And after that, we're going to move into the formulas presented in the experiment. And from there, we're going to look at the experimental procedure and the safety that's associated with it. Then we're going to look at the actual apparatus that the experiment entails. And then to kind of wrap things up, we're going to look at the results of the experiment and the uncertainties and conclusions that come along with it. Right, so let's do a little refresher on the ranking cycle. So in a kind of bare bones system right down here, we have a system comprised of a pump, boiler, turbine, and a condenser. So going from say 1 to 2, we have isotropic work input from the pump. Now, unfortunately, in this experiment, we don't have a pump, but let's just act like we do. And then from states 2 to 3, we have that heat addition from the boiler at a constant pressure. And then from states 3 to 4, we have the isotropic work output at the turbine. And then lastly, from the condenser into the pump, we have that heat rejection. Right, so these are the different formulas that we're going to encounter in this experiment. So we're going to be looking at the thermal efficiency of the whole cycle itself, and then we're going to be looking at the efficiency of the generator, and the mass flow rate of the steam throughout the cycle, and the heat transfer throughout the whole system. Now, starting with the experimental procedure, it starts with kind of verifying that the condenser and the boiler have both been drained, as if they haven't, if we kind of prove danger to the potential experiment, and then we want to fill it up with the water. And then before we want to run it, we want to close this valve so that extra heat goes out so we can read quicker. That goes into turning the boiler. And as we turn that on, you want to pay attention to this computer screen right here and make sure it doesn't go above 758 kPa. And that converts it over into PSI. That's why it says it there. And once the boiler's settled in, then we can start to open this valve right here. And we can start the recorder. And from there, we turn on the load switch, and we keep the voltage to about 12 and the amps to about 8. And from there, we kind of just let it eat for 10 minutes, just kind of let it go. And then we shut off from there, and we have to measure the volume of the water in the condenser and what's left in the boiler before we drain. Now, looking at the experimental setup, so right here is our condenser tower. Here we have the turbine and the generator, and then we have the boiler here, and here is going to be our fuel source. Right, so let's look at results. So starting with fuel flow and boiler temperature versus time, you can see that as the fuel flow kind of stays at a consistent rate at around 4.3, you can see that the boiler stays at that same consistent temperature, and as we shut down the experiment, both the boiler temperature and the fuel flow go down naturally. And then now we have the boiler pressure and the turbine RPM. So as you can see, as it sticks around that kind of 700 kPa, that turbine is going to keep the same. It's going to keep the same energy, right? And unfortunately, as you can kind of see right here, it kind of swiveled down before we shut it off. So there was a little uncertainty in there with the velocity of the turbine. Now looking at the turbine inlets and outlets. So starting with the pressure, we can see that the inlet was able to hold around 163 kPa, which is great. And then as we shut it off, you can see it was going down there. And then with the turbine outlet, that was open to the atmosphere, so that's going to stay the same the whole time. And then looking at the turbine inlet and outlets, these are going to stay the same the whole time as they're moving through. And going forward is, and as it shuts off, it's just going to go down slowly. Now, looking at the generator, we have the chart in the amps. So right here, kind of stays consistent throughout, but unfortunately, kind of right as we shut it off, then had a big spike, which is a bit of an uncertainty there. And then looking at the voltage, it was able to stay pretty consistent the whole time, and as we shut it off, it went down. And then at the steady state of the cycle itself, this is the data that we needed to solve for the results. And from here, we could really go to the tables and find what we needed. And then now we're going to analyze the different components of the ranking cycle. So looking at the boiler, we were able to get the mass flow rate using the MPPs from the steam tables in that last data sheet. So the mass flow rate of the steam itself was 0.0147 kilograms per second, and the heat in was around 37 kilowatts. Now looking at the turbine, the work out from it was about 0.46 kilowatts, and the work from the generator was around 1.815 watts, and we were able to use that to produce the signals again, and the efficiency of the generator was around 0.39%. Now, looking at the condenser, we were able to figure out that the heat out from it was around 37 kilowatts as well. And to kind of wrap things up, to talk about the thermal efficiency of the whole cycle, unfortunately, since we weren't able to have that pump, really a lot of that work that was going to help with the efficiency wasn't there, and so that's why we see such a small thermal efficiency of 1.24%. Now, to look at the actual error and uncertainty and where we thought it came from throughout the experiment, the pressure from the boiler itself was fluctuating, and it really wasn't at a steady value, which was able to skew some of the data, as well as the main thing here, since there wasn't a pump, we really couldn't get that increase in pressure from that pump. The fluid entering the boiler wasn't exactly what we needed it at, and as well as the experiment wasn't run for that 10 minutes. And then for our experiment itself, the O-ring right here kind of crapped itself out, so there's a lot of metal on metal grinding, which deterred us from running the experiment. And that is it. Any questions?